Is that slide up?
Yeah, it's up.
Great. Okay. Hello, everyone. Welcome. My name is Ankur Mehta. I'm a professor here in the ECE department. I've been here 5 years now, so I think I'm finally at the stage where I've been here longer than anybody else in the room, but only by a bit. I've been here and doing research in robotics. My group here is called the Laboratory for Embedded Machines and Ubiquitous Robots, LEMUR. And we do a whole lot of research in the broad field of robotics. And robotics means a lot of things to a lot of people. What we do in our group, we have we study the entire stack. We talk about the mathematics underlying robotics and robotic intelligence, things about sensing and perception, planning and control. We talk about the math underlying it, the algorithms and the computation that goes into it. And we embody that through the physical creation of robots, design and manufacturing. We think about materials, we think about applications, we think about users. We put this all together ultimately for a big picture vision of bringing robotics to everyone. This idea of giving everybody the ability to engage in robotics. Now, if this were a research talk, I would go ahead and break down more of what we do, but I don't want this to be a research talk. If you care about what we do, you can go to our website and take a look. We've got the we have a sort of a broad overview of our research. We have daily or weekly updates on some of our research things. You can come talk to me outside of this talk, and I'm happy to discuss more. Find my grad students and have them talk to you about what is going on. What I'd like to focus on is why is going on. Why do we do what we do? Really focusing on this application statement that says we're taking our abilities as engineers, we're taking our research efforts, and turning that into accessibility of technology, giving that robotic capabilities that we're developing to more people. And the reason is because it has a very specific impact. It matters to us, to everyone, to society. Now, I'm going to go through and I'm going to break down this talk into sort of two phases. One is an explanation of the problem, and then another is some inference as to why I've developed this pathway through research to hopefully come to a solution. The explanation of this problem, I'm going to use a few sources. This first source is a talk that was given as a keynote a couple of years ago by my colleague at University of Michigan, Chad Jenkins. I can't do full justice to the entire talk in my presentation, so I highly recommend you go and view this. There's certainly plenty of technology and robotics knowledge thrown in there, but he goes through this description of the societal issues that I'll be discussing here in far more detail. I highly recommend it. I've pulled out a few individual slides and screenshots from this talk to focus on sort of the setup of the problem. And the problem is, what is engineering like today? Chad presents these sort of three regions, these three spaces of performance that engineering can help with. And there's this idea that the optimal research, the optimal technology development serves to improve technical capabilities, this idea of innovation and excellence, we're building better technology. It serves to improve societal outcomes for everybody, this idea of bringing those capabilities and those opportunities to everyone equally. And of course, it does so with some amount of staying power. Now, for better or for worse, we're in a capitalist society, and so that staying power translates into money. Can that generate more money to feed back to generate more results, more progress? Now, the challenge is that, that being an ideal situation, that being the optimal, doesn't translate to that being the historical behavior. And most of the technical contributions have been down here in this corner where it focuses on, can we improve performance metrics and make money while doing so? And what that ends up doing is separating out the world of performance into two distinct categories separated by this gulf. Things that deal with questions of quantitative engineering metrics, or things that deal with quantitative financial metrics, those all have lived in the world of engineering historically. But all this idea of social benefit is not necessarily considered in the same light. And so we have this gulf. Now, maybe we can think about that as a source of improvement, a source for future engineering approaches. And I'd like to shift a little bit to another source. Another faculty in our department, Ajuta Kadambi, wrote a paper in Science just recently, a few months ago, that got published, that really looked at this and said, all right, well, up until now, we have this axis that we could call performance. Whatever it may be, there's that performance that has historically lived in that quadrant of engineering metrics and financial metrics, and that's been the driver for progress going forward. But we can extend that, and we can take a look at this idea of social benefit. Now, he termed it fairness, and he came up with a quantitative metric, epsilon fairness, and presented this idea that if we even living within the same performance metric, if instead of focusing on enhancing that performance, if we instead focus on enhancing that approach, the equality or the fairness of the technology we do, we're pushing out this Pareto front. Now, this Pareto front represents some arbitrary surface along which there's no strictly dominant technical solution. But of course, if we leave the performance where it is and simply increase the fairness or the equity in our solutions, we are generating progress. We are doing better. So this should be this should also be a valid engineering outcome. I want to take this idea and
I may interrupt and just ask a quick question.
Yeah, please do.
Yeah, if you could please explain a little bit more what Pareto optimal and Pareto inefficient mean exactly.
Sure, absolutely. So this idea of trade-offs happens throughout engineering, and this graph that we have here, it could be any two axes. I'll go into a little bit more detail later on, but the idea here is that you have two different things that have competing effects on the engineering that you're doing. In this case, these axes are labeled majority performance and fairness. If you're talking about like an algorithm, you may talk about accuracy versus computational cost. If you're talking about your the robots that you buy to clean your house, you may talk about how clean your house gets versus how long it takes to clean your house. And all of these things have a trade-off. You improve one at the expense of reducing the other. Now, where is the optimal trade-off? You can say that I want my house 10% cleaner, and I'm willing to wait twice as long to do so. Maybe somebody else won't have that. But you certainly won't want to say, all right, I want my house exactly as clean, but I'm going to take twice as long to do so. So the idea that there are some solutions that are strictly dominated by other solutions. There are some solutions that no matter what your relative value you place on those two axes are always going to be better or worse. That's something that lives underneath the Pareto curve. Points along that trade-off which you cannot directly compare without knowing your individual relative value, those live on the Pareto curve. And if there's no way of generating a new solution that strictly dominates any particular solution that you have, then you are at the Pareto optimal. But if you're not at that optimal, if you're below the curve, then you are inefficient because you can improve any one dimension of it while leaving the others where they are. So in this case, point one is inefficient because without changing that performance metric, you could potentially improve fairness. And that is strictly better. There's no reason not to. I mean, point one is also inefficient because without changing fairness, you could improve performance. Now, anywhere along that black curve, that curve is the optimal curve. You can't improve one without reducing the other. We don't have that technology yet. Now, I will go back and revisit this. Actually, why don't I just address that right now? So this is this idea of the trade-off where you let's abstract it all away and let's think about these two axes, where one axis is performance and the other axis is this idea of fairness or equity. And when we talk about Pareto, we're saying that as long as you leave one constant, as long as you leave the performance constant, increasing that other one, increasing the other axis, will necessarily be a better solution. Now, if we just look at it in terms of those two axes, not in terms of this Pareto curve, if we ignore this curve, if we ignore the inefficiencies or optimalities, we can go ahead and decouple those two axes. We can say, all right, well, now we have two separate metrics. We don't need to necessarily consider the trade-off between them. We can say, all right, well, we have performance on one line and we have equity on the other. Now, this is by doing this decoupling, this is what Chad was referencing when he's talking about this gulf. That one set of performance metrics, and this contains a whole bunch of things. This is talking about number of transistors or size of transistors or speed of computation, lives in one axis. And this other axis is this idea of fairness, of equity, of providing benefit to everyone. Now, what does that mean? What does that mean in terms of what we actually want, which is progress? We want to be technically relevant. We want to improve, innovate, and be excellent. Well, if we do this separation, if we take this trade-off, whatever this two-axis trade-off may be, and only consider one axis, in this case, again, going back to this idea of performance, we can say, all right, what we want to do is we want to improve performance. We want to take wherever we happen to be and make it better. Now, this is not, this idea is true across engineering. We can take a look at this and say, all right, if I'm doing a robotic solution, I'm going to get faster. And that performance axis is faster. And I'm going to ignore any other concerns. The fact that it consumes more fuel, the fact that it gets hotter inside the cab, it doesn't matter. I'm just getting faster, right? What we're saying when we decouple this is we're ignoring that other axis, wherever that happened to be, wherever the previous technology happened to be, we now improve the one metric of performance, and we'll be at some other point along that other axis. Now, again, this is not unique to any definition that happens to be on that vertical axis. We do this all the time. I myself have fallen victim to this approach, where I say, all right, well, this performance axis is just the weight of this system. And I'm making something lighter and lighter and lighter, and it makes and therefore it's better. It is a useful outcome. But I don't consider that other axis. Maybe that other axis is accuracy. Maybe that other axis is fuel efficiency. Maybe that other axis is equity. And what has happened now, as we focus exclusively on those engineering metrics, of course, if we had ignored something like fuel efficiency or accuracy, some other engineer would probably have stepped up and offered a rebuttal. What happens when we ignore this equity axis? Who's there to offer the rebuttal? What ends up happening is we may end up finding points that are not only slightly lower in terms of that other axis, in terms of the equity axis, they may be below that Pareto curve altogether. We've gone from a technology that was Pareto optimal to a technology that was Pareto inefficient by ignoring that connection, by ignoring that direct trade-off. Is this innovative? Is this excellent? Is this the kind of engineering that we want to do? When viewed in this light, it becomes very clear that, I don't want to be doing this kind of engineering. I don't want to be seeing these things where the outcome of my work is worse than the outcome of previous work. I want to continue to do better. So now I want to say that this view that we've been improving performance while neglecting this. It's not just a theoretical argument, just in terms of these two axes and dots on a line. Again, going back to Chad's presentation, he presents this one particular set of graphs, which is, on the one hand, we have this idea of Moore's law of technical capabilities and the engineering outcomes, those metrics that are along that bottom axis, have been growing exponentially. We can plot all of them, and we do plenty of times. What about another axis? What about societal cost? What about societal benefit? In this case, along that same time horizon, the number of I guess the members of society that have been left behind, that have not been able to participate in this kind of technical advancement has also increased exponentially. In this case, we can take a look at this graph and we can say that it's it's a graph across Americans that are in jails and prisons. And at this point, I'll take a quick break and say that most of my the graphs and metrics that I'll be presenting here are limited to America. I think it's easier to come across data from there. There may be relevant things that are more global, that are more worldwide. I don't have that right here, but it's certainly worth thinking about as well. But even here within America, we see this. And of course, this particular metric, this particular graph, here we're talking about incarcerated Americans, or Chad is talking about incarcerated Americans. And of course, that is overweighted towards people of color, which means now there's coupling between role in society and role in life and demographics. Now, there's certainly much more to dig into here, but this is where I start to make a little bit of a shift and start saying, here we can see these two graphs, that technology progress is increasing, that bottom axis along the curve, and that the equity axis, that the equity across society has been decreasing, that the society has gotten more unequal. Are they coupled? Are they correlated? Is there any connection between there? Now, I obviously, because I'm asking this question, my answer is going to be yes. And I want you to think about, as I go through these things, what does this mean in terms of us? What does this mean in terms of engineers? What can we do about this, especially since we're talking about technology and the role of technology within this? Now, this is a much more complicated topic than just, technology. This is a much more complicated topic than any one of us can hope to solve in its entirety. The thing is, though, one element of this is what I'll be presenting, and even that is something that we can have agency over. And so that's what I want you to be thinking about. This is absolutely not the full story. There's plenty more that's involved in here. Don't necessarily view that as saying, well, what about this other thing? Let's not do this. Think about what can be done here. So let's take a look at this breakdown, this idea behind technology and societal challenges and all that. Like I said, we live in a capitalist world, in a capitalist society. And so as hard as it may be to reduce everything to that one vertical axis, we can try to do so using the proxy of money, because that's the world we live in. And sure enough, that one axis is demonstrating an increase in separation. That as time has gone on, there's been a larger and larger separation between those who are benefiting from societal advances and those who aren't. The income gap has been growing steadily over the past years. Now, income represents money that you're getting every year or on a regular basis. It's the time derivative, or it's the time derivative of how much you have. So if you integrate that, you'll go to wealth. This is how much how much individuals have accumulated through current and past income. Now, of course, there's also plenty of systemic issues that breaks this particular integration relationship. But even, this is why we look at both of these metrics. The same thing happens. The rich are getting richer. The income separation is getting higher. The wealth gap is getting higher. And the most important thing to note is that the bottom of the chart, the bottom 50% of the American population now has even less wealth. They have less. Now, wealth is a proxy for everything that you have, everything that they have. And in fact, according to these metrics, 10% of the population has less than nothing. So, okay, so we can very clearly see that along some equity axis, we are going down. Society is degrading. It is getting worse along some metric of fairness. Now, what does that have to do with technology? Well, it turns out that there is obviously a correlation between money and technology. Technology costs money, and therefore you can, I mean, these graphs should come as no surprise. Those who have less, in terms of that thing that unifies all metrics in a capital society, that money, those who have less money also have less access to technology. This could be, these are in particular talking about connectivity, but you know, the idea that connectivity relates to technology abilities, capabilities, is sort of very, very clear, where how much of life happens online, how much of life happens through interactions. With less access to that, there's less access to everything else. So you can see that, you know, the lower income demographics have less in terms of technology. Now, this is where I will start focusing even further. That lack of access to technology translates to lack of access to education. And this past year with the pandemic has really highlighted that correlation, where there's been plots of this that you can see on the left-hand side. It's where, who has technology, who has access to technology, the connectivity and the hardware used to do that. Now, in this case, it's broken down by demographic. Of course, going back to those earlier connections, there are systemic correlations between the demographic and the income levels. And that directly ties into the performance. Where there's less technology, there's less access to education. And so you can see sort of there's these steps that we're going through. There's these steps that we're now using to connect technology to equity and to fairness. Now, these are these metrics were taken at the primary school level, and you can see kindergarten through 5th grade. Those who have less access to education. Now, we don't need to make that jump entirely. We can just go directly from money to education. Here's another view of how does income levels, how does that access to money translate to educational levels directly, in this case at higher education. And where the key takeaway is that you know, the vertical axis here is the income levels that the students have. The color measures sort of, again, however you map it down to one dimension. The color maps to one metric of quality of education. And there's this very clear trend that the more you have, the better education you have. So where are we going with this? Just going back through what's been going on. We started with this idea that that there's been an improvement in technology. There's no doubt about it. There's been improvement in technology, but that improvement in technical performance has not come with a corresponding improvement in equity and uniformity across that. And we can see that there is not that that there isn't that corresponding improvement in access to money, in access to technology, in access to education. And all of those are coupled through those various things. And now let's close that loop. There is this positive feedback loop. Now, when I say positive feedback, I mean in the engineering sense, where positive feedback is a bad thing. It causes things to rail out. It is why the gap continues to grow. And here's some other analysis from the Federal Reserve Board, that without that education, without access to that education, you have less. You have less of an opportunity to improve even thereafter. In this case, it's looking at GDP, that quantitative production value, again, reduced to one axis, which is that money axis. There's obviously some delay in this because, you know, people are at various stages through the pipeline currently, but there's this forecast that those who have been impacted by this lack of access to education are going to be stunted in their capabilities going forward because of lack of access through those entire sets of consequences, of cause-effect relationships. So where does this all happen? What does this all mean? Where does this all come to? This idea is that there's a loop, and this is the loop that we have been observing over the past decades, that without access to technology, you don't have education. Now, this idea of having access to education is that one element that I've been focusing on, but of course, there's many societal aspects that feed into this same loop. With that, you then have less of an opportunity to break that, to break out of that and get access to more wealth and income and money that will get you that more technology. And so when you have less technology again, you have less opportunity to break out of that cycle. It's a positive feedback loop. And we need to break this. And this is where I want to bring this to all of you. Now, what did I do? In our group, what we focus on is breaking this by breaking out this access to technology. The research that we do in our group is very much about democratizing access. When we go back to that Pareto Front, we focus explicitly on improving that other axis, which is access, which is fairness with inequity. But that's what we do. That's how I try to drive forward. I want to put this to all of you. You are all engineers here. You all have the ability, the agency to enact some kind of change. How are you going to live in this conjunction, where of course we want quantitative improvements in engineering outcomes. We want things to be faster, to be better, to be more accurate, to be lower power. We want that to translate into some kind of staying power. We want that to turn into some amount of ability to improve even further later on down the road. That's this idea of market performance, getting more money out of it, taking your product and selling it to be able to build and design that next product. But we want to always do so with the knowledge that there are people on the other side of that we want to be able to improve those people's lives. We want to be able to improve everyone's lives. We want to think about how the engineering that we do improves society as a whole, not just that one metric that gives us that next paper, that gives us that next product, that gives us that next round of venture capital. We want our impact to live at the intersection of these three effects, so that we can actually push that Pareto curve out, that we can make that optimal more optimal, but not just for a small subset of the population, not just for those that have always been reaping the benefits of engineering progress, especially for those who have not, so that we can reverse this trend, so we can break this cycle, and so that we can move towards a society where everyone can participate, where everyone can be a part of this, and where as a whole, we are now a happier and more unified set of people. So with that, I want to have this go into a discussion. I want to use this to inspire some questions and inspire some thoughts. How do we go with where we are, what we've learned, what we've done in our years of education here and before? Where do we go from here? How do we focus on these things? I'll put that to you. Let's. I'll stop sharing here, and then we can have a conversation about this. How do I stop sharing? What have you all been thinking about? What did this this conversation, these sets of slides, this analysis inspire in you? What can you do? So I can talk a little bit about some of the work some of the more technical work that's been going on in my group. You may have heard of some of the research that I've been doing, either by talking to me, by talking to my grad students. This idea that accessibility is the key driving factor is the premise behind our work on $1 robots, where let's define a research result. Let's define a technical capability, not in terms of speed of robot, not in terms of strength of robot, not in terms of accuracy of algorithms, not in terms of computational power, but in terms of how many people can make use of this one device. And that's the idea behind the $1 robot. Now, it turns out there have been plenty of technical challenges to get to a robot that costs $1. There's been material challenges. How do we make things out of material that's easily and readily available? Rather than using plastics and metals and woods, let's use paper. Let's use paper without any precise material specifications. Well, if you can't rely on your materials, you need to rely on your design. All of a sudden, now we have research questions around how do you design around inadequate materials. Now, when you have inadequate materials, when you have materials that are not as good, and you need to build things out of them, you also need tools to do that. And now this goes not only to materials, but manufacturing processes. It does you no good to build a $1 robot using $1 million manufacturing tool. That $1 robot needs to be coupled with 10-cent tools. How do you do this using just your bare hands? Maybe a pair of scissors. All right, and now we put all that together. Well, again, having something that costs $1, that requires a few cents of materials and a few cents of tools, does you no good if you need to go through an elite education for 18 years in order to be able to understand how to do so. And that translates into the user interface design. How do you do computational design using tools that are accessible to non-engineers? If you don't have access to the UCLAs of the world, can you still create? Can you still design and employ and use? So starting with that question of what would make things more accessible? What is preventing somebody from accessing the robotic technology that was presented in last year's robotics conferences? And then translating that as the focus of the research. That becomes the opening move in a whole range of new research. So that's what I've been doing. How about you? Maybe not what you've been doing, but now what about what do you want to do? What does this, what do you think about in terms of what you can do? Or do you have questions? Do you have questions about what you have been doing so far, and how do you adapt that? How do you translate that?
Hey, Professor.
Mm-hmm.
Yeah, just got a question. So based on what you were saying, it seems to me like, so now we are trying to make the technology like cheaper so that people have like, financially can support for using the current technology. And also, would you also imply that to make, try to make the technology is like more easily to use, like making a black box so that people don't, who maybe not have that kind of knowledge, like that deep of knowledge into robotics, but still can, apply them to the applications they wanna build. It's like both of them. Your lab is approaching to, or maybe one of them.
Yeah, so our lab certainly handles both of those, and I think you bring up you've mentioned a very good point that those are two separate avenues of research. One is lowering cost barriers, lowering the barriers that come from what you have, and of course that translates into using developing research that has a lower monetary impact. But there is also that question of experience, of expertise, that is also another barrier to access. And that you can, if you recall back to some of the slides on access to education, sure, there is a connection from those financial resources to access to education. If we can bypass that step altogether by requiring less expertise, by requiring less engineering knowledge and less years of education to access the benefits of that technology, that also provides another step towards increasing accessibility. And so we do that as well. This idea of building the tools that encapsulate as much of the engineering knowledge as we may be able to, so that the user, the end user, the person who stands to benefit from this technology can do so with less of an investment of time into that same direction. Now, we're doing this largely focused on robotics, but that's by no means a requirement. You know, I think robots are fun. I think robots are cool. I showed the graph earlier about the performance in primary school. That's part of the reason why I like to go to robotics, is because robots are compelling technology all the way down to kindergarten and first graders. And so, you know, that's where I've been focusing at least my interests in terms of robotics. But it doesn't need to be just that. Cell phone and laptop and smart computational platform technology is another area where this may be relevant. Certainly, there have been efforts on this in the past. The OLPC or the EPC have been the one laptop per child, or those efforts have also been going towards this idea of accessibility. And you know, again, this idea that how do we minimize barriers? How do we reduce barriers? How do we increase accessibility can be addressed in many different ways. Money being one, expertise being another. What else?
So I have a, I guess, more fundamental question about robotics, which is, what are your thoughts on the overall societal benefits versus harms? You know, I think the harms are sort of clear in terms of job loss, and certainly there are foreseeable benefits. But what do you think about how those, you know, weigh?
Sure. So I think that's a question that's been very, very visible in the public discourse lately. I may take a step back and say that it's not so clear. This idea that there's a harm to be done by robots translating into job loss. I'm not necessarily sure that connection is directly clear. We can take a look at every new technology that has been created over the past 200 years since the Industrial Revolution. And sure, they've all caused job loss, but they've also resulted in improved standards of living for those who would otherwise have been forced to do to spend their bodies in order to survive. Now, the promise of robotics is that people will not have to do so. But that promise, again, can only be realized when there is equal access to this technology. And so again, it comes back to this question of accessibility. The dangers of job loss due to robotics happen when the jobs that are lost and the livelihoods that are lost are not able to be regenerated, are not able to be repurposed because of barriers preventing those from accessing the benefits. For example, those when the water mills came to were sort of one of the big drivers of the Industrial Revolution. This idea that we could, instead of harnessing human power, we could harness the power of the environment. Well, it took people from those who were pushing the millstones themselves to those who were then turning the flour into bread. Those who had been driving the looms themselves were now the ones that were designing the fabrics and being able to sell their creations that way. Now, of course, any significant change in technology comes with some friction. There's always people who will be negatively impacted. And as always, those that are the most negatively impacted continue to be those at the bottom end of the spectrum in terms of the haves versus have-nots. But what's happening is that those gaps have been separating further and further. And because of this lack of access, there is not as there potentially may not be as much of the opportunity to rebound. Now, I'm not sure that has to be the case. I think if we put an active effort towards trying to achieve similar outcomes, where now nobody needs to go into a factory and sit on or stand for 8 hours trying to put stuffed teddy bears into boxes. Well, what could they do with their 8 hours of life? They could perhaps run their own warehousing. They could generate their own value if they had access to the technology to do so. And so I think that's the question. I think robotics as a technology is no different than any other technology that has existed in history or that will exist coming forward. I think the question is largely one of engineering as a whole, which is this single-minded focus on quantitative performance and on monetary output at the expense of accessibility to those benefits is what is the challenge in society.
Gotcha. That's an interesting take.
So when you say accessible, what exactly do you mean by accessible? Because like everything I know about programming and electrical engineering is on Wikipedia, but that doesn't mean anyone can just go on Wikipedia and teach themselves everything I know. So what do you mean like by accessible? Like what's your definition of that?
Right, that's a very good question. You know, this idea of how do we define accessibility? How do we improve accessibility? Comes from a position of, you know, we need to view it from a position of what, you know, I guess, you know, we have certain privileges, or maybe I can say I have certain privileges that impact my view of what accessibility means. And that this idea that there's certainly been a lot of discussion about how these open source educational initiatives, Wikipedia being one of them, should improve outcomes without understanding perhaps some of the other correlations. Now, you know, one of the slides that I had up earlier was the fact that access to the internet is already unequal, both in terms of the hardware required to access the internet, as well as the connectivity required to access this information. And so we can't simply say that having information on Wikipedia defines it to be accessible. What we can say is having that information available on Wikipedia and on YouTube and on edX and Coursera, which is certainly a step up. It is an improvement over the situation where you couldn't have access to that without being a member of these elite institutions. So that's one step forward. But there's more that needs to happen. Now, it's not just a matter of that technology. It's also a matter of having the time and the mental effort that can be addressed, that can be allocated towards accessing that knowledge. And I think this is where some of those conversations around, robotics are taking away jobs, may be a benefit. Where if you didn't have to spend your time and your mental effort to such a degree on survival, then perhaps you could allocate it towards accessing some of this information and learning more. But of course, that's making a lot of presumptions. That's making a lot of assumptions or a lot of expectations around things where, I'll say that I don't have necessarily the direct experience behind a lot of it, and I can observe that it's not so easy to make that happen. And so that's where this idea of trying to, at least in the work that we're doing, trying to abstract away the required knowledge. How do you benefit from the knowledge that has been codified in terms of how to write code, how to program, how to do how to solve problems algorithmically? How do you make it so that you don't need to necessarily understand all of that? You don't need to learn all of that, but still reap the benefits of that. And I think that's sort of a more general question, a much broader research question in terms of encapsulating knowledge, in terms of employing knowledge without knowing why. How can you say that, all right, without knowing the fundamentals of programming, without even knowing what computational thought means, how can you develop an algorithm to solve a problem that you may have? a lot of this shows up in the field of HCI, human-computer interaction. There's work that we've been doing where it's this idea that maybe instead of thinking about engineering contributions in the sense of you learn how to do engineering and then you do engineering, you think about engineering contributions in that the tool learns how you think and it does engineering. I don't have that slide immediately available, but I had a visualization of this where we want to move from this idea of the user driving forward progress to by pushing to the user guiding the progress with the tools and technologies being the motive force. And so in my mind, at least, I feel like that is a way of describing accessibility that hopefully addresses some of those challenges. Now, as always, that's one set of approaches, and that doesn't work for all of the challenges that have that society is facing right now. So, I throughout all of this, I'm as much a student as I am a teacher, and this is why I like to have discussions and why I like to bring this up. What am I missing? What is it that I haven't seen yet? What is it that's something that we can do, not just me, but all of us together, to see these shortcomings and address them and work to make them better?
So it's kind of like a Web 2.0 where you take like complicated like HTML and you turn it into a set of buttons that anyone can press.
I think that's certainly been the promise behind a lot of that. This idea of abstracting away the process steps. Now, there's certainly been a huge challenge in that Web 2.0 vision, in that the benefits of doing so have largely been constrained within the providers, and there needs to be some perhaps technical, perhaps non-technical solutions that prevent I guess the service provider from taking advantage of the content producer. So I think taking taking inspiration from the whole Web 2.0 approach where it's merited, and then addressing the aspects of it which have not generated the results that society intends, would hopefully be the next 3.0 or 4.0, whatever it may be. So does anyone have any suggestions, any thoughts? Like what can we do? I think there have been a lot more issues than I presented. I think all of y'all have who've spoken up have brought up more issues as well. What maybe a project that you've been working on, maybe a project that we've been working on. What are things that we can take a look at? We can take a look at cost. We can take a look at engineering skills required. Are there things that we've missed? Are there other metrics that we can assign to our engineering outcome that could improve accessibility, that can serve to break this cycle and improve the equity across the users and participants in this technology?
Hello. Thank you for taking your time and like discussing like all of this. Like it's definitely a new like perspective, because like typically like when we're in classes and stuff, we never really think about like the equity side of things. Like it's always just like performance, like even for like class projects and stuff. So I guess like one thing like I wanted to add on was I think like earlier you discussed about like HCI, and I know that for like human computer interaction, like sometimes like when you're doing like projects, like you have to conduct like user studies. And then what I've like noticed is like sometimes like those user studies are like with like really niche groups. So like I think a way of like improving accessibility is maybe just like making sure that like user studies are like applied to more people and more different people. And also I guess yeah, I just kind of wanted to like hear your take on maybe like user feedback for like different like applications and like maybe for like robotics as well.
Yeah, great. Thanks for bringing that up. I think that's a very important point, which is that, you know, it's very hard to advance the causes of equity and very hard to improve accessibility when you're only viewing one side of the story. And I think this was explicitly brought up in both Professor Jenkins, Chad Jenkins' talk, as well as in Achyuta Kadambi's paper in Science, that participation is key. Participation, of course, in the studies and evaluation, also participation in the actual execution of that development. And you know, I think there's a very key point to be made there that we need everyone to have everybody who's a stakeholder, everyone who has some skin in the game, which is everyone, should also have a seat at the table. We need to do what we can to get more people involved in the development, in the testing, in the evaluation, and in the use of all this technology. And so your point is absolutely dead on. We need to expand the participation throughout the entire chain. Now, what does it take? It takes effort, right? It takes effort to gather and access those people who have not been historically included in these kinds of conversations. And my this is my missive, is that effort should be rewarded as you all go on and leave your lives here and move on to the next phase of your lives. If you're ever in a position where you can choose what rewards to assign, think about this. Think about the fact that it doesn't come free to reach out and get more people. It's very easy to get volunteers from your classmates. Very easy to get people to join your engineering partnership from those you went to school with. But if those you went to school with, if your classmates and the people who live in the same office and that work with you are not representative of the people who comprise your society, then it takes some more effort to make those changes. And that becomes something that adds value. That is something that should be rewarded as excellence, as a beneficial outcome, as impact that's generated. Now, as it stands right now, you know, certainly I have far more power than any of you because I have, you know, a job that pays me money. But eventually you'll get there too. And having more of these discussions will hopefully continue or help force a shift in the approach of or in the direction that engineering is going. And hopefully that translates into a change in the outcomes in the direction that we would like to see.
I also have a question about so for robots, a lot of the times they're rigid, right? And once you build them, they can only do that thing you built them for. When Steve Jobs unveiled his like iPhone, a major power of that was that, you know, you could tell the iPhone what you wanted it to do, whether through code or through an app that you made. How do you think you're going to address the challenge of just allowing people to have a robot that can do what they want it to do rather than have the robot that was built just do what it was built for?
Yeah, that's a question where if I if I hadn't had if I know that I haven't asked you to ask that question, that would be the question that I would ask somebody to ask to lead into my research talk. The first slide or the first two slides that I give in my research talk are always exactly that question, where the smartphone revolution, this idea of computation in the palm of your hand or in your back pocket, has made this idea of accessibility due to creation somewhat achievable in the space of computation. But that's not the case for robotics. And the problem is that robotics is just a lot harder. Computation lives in a very well-defined, well-bounded world, numbers and bits and bytes and it all turns into math. Now, math is not easy. It took a long time and a lot of developments in engineering to get us to the point where somebody can create a computational solution for a problem that they may have. Physics and physical systems live in a much larger, much more diverse world. There's noise sources and there's uncertainty and there's continuous variables and there's people. And all of this makes it a much harder problem. But that doesn't mean that we can't solve it. We can take an approach from the computation playbook. How did computation get to where it is today? One example or one thing you can point to might be transistors. And by abstracting all of things all of the solutions that you could possibly achieve into this idea of, well, let's just do zeros and ones with little tiny switches and see how we can relate all of our problems down to that. And then we focus our engineering effort on making better transistors and about combining transistors into making solutions. And all of a sudden now we have a watch that has more computational capacity than the thing that took humans to the moon. Can we do something similar for robotics? Can we come up with that fundamental atomic unit that on its own doesn't do a whole lot, but can be integrated in large scales to generate physical solutions? Now that's a very hand wavy, broad approach that doesn't really translate into anything concrete, achievable. But in a sense, this is where I try to direct our work in the sense of making modular and hierarchical components to robotic design. We have these individual bits and bobs that can contain some amount of intelligence, some amount of structure, some amount of actuation and sensing. And by being able to combine them in ever more complicated systems, we can hopefully get that abstraction, that design abstraction that separates how do you realize a solution from how do you conceive of a solution. It's a work in progress. There's a lot of effort that needs to go into it and a lot of engineering that goes into it, and that's what research is all about. Great. So I don't know how much time we have here. I'm happy to stick around as long as people want to talk and discuss, and we can talk about the broader picture. We can talk about very specific questions. I'm happy to stick around, but before more of y'all drop off, I do want to leave you with that charge, is to at the first step, think about that kind of impact. Think about not only your impacts in terms of pushing forward the state of the art in technology, not only in terms of making money and generating economic growth, but also in terms of the societal impacts, in terms of accessing people that may not have otherwise been accessed, in terms of enhancing lives across the spectrum from everyone who could possibly make use of this. So hopefully this conversation gave y'all something to think about, something to consider, not just tonight, not just the rest of this week, but hopefully for the rest of your your life as an engineer and as a human being. If you ever want to discuss anything further, you should always feel free to send me an email. I'm happy to discuss any of these topics with you, and bring me ideas as well. I think I have a lot to learn from all of you just as much.
Hey, Professor.
Mm-hmm.
Yeah, a question on how your lab is currently working on reducing the cost of robotics. If you would like to talk about that, and also what some current challenges on that.
Sure. Yeah. In terms of just the reducing the monetary cost of robotics, I think that's been one of the driving factors of my lab for the past many years. This idea of manufacturing. How are things built? Robotics need some kind of robots need some kind of physical embodiment. What if we could build it out of things that everyone has access to, or at least a lot more people have access to? There's been a lot of development on making structures from 3D printers, and 3D printers definitely did a lot in terms of improving accessibility to structural manufacturing. Now you don't need access to a machine shop. You don't need raw materials in terms of metal and wood. You don't need tools like mills and lathes and CNC machines. But you still need a 3D printer, raw material in terms of plastic filament and the machine. And in fact, one of the other things you need is access to reliable infrastructure. If your power cuts out in the middle of a build, you're out of luck. You have a pile of spaghetti and you need to start again. So instead, can we move away from that paradigm and still have that same performance, the ability to create everything, create whatever you want out of materials that you already have and tools that you already have? And that's this idea behind building things out of paper, and when I say paper, I mean, any arbitrary planar, flat, thin film material. Maybe you have a pile of newsprint. Maybe you have some cardstock. Maybe you have a sheet of polyester plastic. You have some 2D material. What can you build out of that? What is it that, how can you design structures out of that in such a way that you can create functionally specified mechanisms? And so that's a big area of research that we're doing here, which the fundamental goal there is, how do you reduce the cost of this? Now, the structure is not the only thing that goes into a robot. You have the structure, you need some kind of actuation, you need some kind of sensing, and you need some kind of logic. And so we have a research project going on now, which is, how do you do all of that? Sensing, actuation, control, again, with low-cost materials. Rather than buying a microcontroller and a servo motor and a light sensor or a thermal sensor, can you do it all with again, paper and string? Now you can get conductive string, you can get silver-coated nylon, and it has some interesting electromechanical properties. What can you do with that? What are just exploring the space of capabilities where the driving factor in where you choose to explore is fundamentally the cost. So that's some of the work that we've been doing sort of directly in lowering the cost of robotic systems. But I think the second order effect has also been this idea of now taking that, and every time we do some kind of design, whether it's using paper and string or whether it's using conventional robotics materials, figuring out what that means in a more general sense, not only for that one design that we have created, but an entire class of designs around that one engineering point. So that when somebody else wants to create their own custom version of it, they don't need to have the expense of trial and error. They don't need to have these levels of iteration. They don't need to have gone through an engineering program and an engineering degree. They don't need to live within an engineering research lab with access to a bunch of facilities before they can even get to the point where they can have a potential design. So every time we make a design, every time we realize a solution to a problem, we think about that within the framework of how does that generalize? How does this solve more problems than just the one that we started with? And the hope is that that too reduces the cost of the solutions that we've created.
Outside of research, where do you think some of the areas of the intersection between, or where the incentives of capitalism and applications of robotics that can have positive effects of society, where do you think those areas are? But both for my personal interest and because I feel like when incentives are aligned, you obviously get the best results because everything can't happen in research.
So I guess there were a few different parts of that question. Can you sort of explain a little bit more where what you're interested to discuss more? I think there's questions, of course, of what lives within research versus what lives outside of research. There's questions of economic incentivization in regards to the accessibility. There's questions of where else can these things provide benefit? What sort of where are you?
Yeah, sorry, it was a very, very broad question. I don't know. I was just thinking of some applications, like, I don't know, maybe like drones to delivering medicine in like rural areas. I can think of sort of some areas where there is sort of some capitalistic sort of benefit, but also a human benefit. I was wondering sort of where other areas you see sort of that cross section, and whether it's just going to be a very small intersection, or whether you think there's a lot of promise in that expanding.
So this is getting to a much more philosophical question, and I think I can answer it in a way that aligns with sort of my beliefs and my philosophies. Other people may have different ideas about this, and I don't know if there's any necessarily right answer or wrong answer. But fundamentally, the question is, to what extent is capitalism compatible with humanism? To what extent is can we make it financially viable to help those who don't have the finances to contribute? And I think my philosophy, my approach to this says that that's fundamentally a misguided question, which is that this idea of trying to find an economic incentive to do the right thing is very hard to derive the right answer out of. That there needs to be some inherent value to doing the right thing, to helping people, to improving the status of society as a whole. Now, the central premise behind capitalism, at least in my interpretation of it, and sort of the way this has been approached for the past decades and centuries, is that maybe you can view this as the rising tide lifts all ships. That as long as you increase the standard of living for anyone, whether they can whether they're somebody who has the disposable income to spend on it or whether not, that still has some expansive effect on everyone else. That the existence of this level of inequity in the haves versus the have-nots is overall a detriment to everyone, including those who have. And so you can say that you can take a look at that in sort of a utilitarian way, which is, if it weren't the case that that rural parts of the world, or that dense parts of Los Angeles had a lower access to healthcare technology, then we would have had less of an impact of the pandemic throughout the higher class, higher socioeconomic classes. And the pandemic affects everyone. Now, it doesn't affect everyone equally, but had there been a concerted effort to improve healthcare in places that didn't have as much resources last year and the year before, then the impact of the pandemic on society overall, the total aggregate, would have been lessened. And so you can view it in sort of that utilitarian sense, the enlightened self-interest approach. Now, again, I'll say that my personal philosophy doesn't lead me to believe that is the right way of viewing it. But by making that argument, by making that case, you can show that there is a financial benefit to helping. This idea that having cold chains to in the face of insufficient infrastructure, that you can deliver vaccines to remote parts of the world, that you can treat those with illnesses around the world and in places that have lacked access to this, serves to improve all of society, right? And so you can make that claim and then translate that into economic incentive. I mean, provided that somebody's willing to buy it. Some people are, some people aren't. I don't know how to address that question in any further detail. It now ties into humanity, into society, into what drives individuals, what drives people.
Yeah, no, it was a pretty broad question. I don't necessarily agree I don't necessarily think in that utilitarian sense either, that like you need to have that justification for helping, but I see how that can be applied. Right.
And I think that's the thing, is that, there's 9 of us left in this room, but there's a couple more that are not in this room right now, almost 7 billion more. And everyone has their own views. And this becomes now an opportunity where we have our intended outcomes. We know what we want the world to look like. How do we convince others with different views of that? Some who have that utilitarian view, some who have a much more severe view of how things should be. How can we still work with them and end up in the situation where we'd like to be? It's a hard question. Everyone approaches that differently and addresses it differently. One of the things that the reason that I've given this talk is hopefully just having more conversations around it with people who can then go out and spread and continue to build on that, and hopefully translate into progress. I'm glad you all have stuck around and are asking these questions. I think having these discussions and working through some of these questions is certainly one of the first steps to pushing forward with it. But of course, it is just the first step, and there's more that can and should be done.
It's like currently 6:19. I just want to respect everyone's time. No one else has any questions. I think I'll probably close the room in like a minute.
Yeah.
I really appreciate you speaking, and because I have thought a lot about what interests me versus what is actually good for society, and it was interesting. It was good to hear your thoughts on the matter.
Yeah. And I appreciate hearing all of your thoughts. Everyone who spoke up, asked some questions, and participated in the discussion. I think it's helpful and worthwhile for all of us. So let's keep this conversation going. Come by, send me an email, and we'll talk further.